All right, you guys, today I want to walk you through the proof for the law of cosines. So just like the law of sines, we're really proving it using our basic right triangle trigonometry and also a little Pythagorean theorem. So you're going to see some algebra in this proof today. So in this proof right here is our law of cosines. So a squared, so here is a, and then here is the angle that is opposite. So we're saying, okay, this side, a squared, is equal to b squared plus c squared. So b and c are just the other two sides. Okay, minus 2 times b times c times cosine a. So what's really important is that we see that we're looking at the a and the a here. So the angle and the side opposite. We are either solving for a missing side or a missing angle when we're using the law of cosines. Okay, so picture this visual to start things off. And again, we are either solving for an angle or a side opposite. All right, so here's how we start the proof. We draw in the altitude from B with a height of h. So the altitude is that segment, that perpendicular segment that connects a base to a vertex. Its measure is the height, so we're calling that h. So right here, we've drawn in the height. We're going to split side B into two parts. So if this is side B, and I call this one right here, if I call this leg now, if I call that x, well, the other leg is going to be b, but take away x, like so. So I can see that really what we've done is we've taken a triangle, we've drawn in its altitude, we've split it into two right triangles. So I have this right triangle over here, where I have sides x, h, those are the legs, hypotenuse is c, and I have this right triangle over here where I have legs that are b minus x and h, and the hypotenuse is a. All right, so now let me go down to right here. I'm going to look at the triangle that's on the left. Let me slide this up. So I'm looking at this triangle right here, so I've drawn it out separately. So if I look at where angle A is, and I write out my cosine ratio. So cosine is the adjacent to the hypotenuse. So that's x to c, adjacent hypotenuse. And then if I resolve that equation for x, I can multiply each side by c and get it in this format right here. So x is equivalent to c times cosine A. Another relationship that I can see is really just the Pythagorean theorem. So I know that my two legs are here and here. So h squared plus x squared equals the hypotenuse squared. And I've just flipped it around to write, well, my hypotenuse squared is equal to h squared plus x squared. Again, just Pythagorean theorem. So basic trig, Pythagorean theorem. All right, so now what about that second triangle? So that second triangle is this one right here. My legs are h and b minus x, and the hypotenuse is a. All right, so here's how we start it out. Let me get my sheet so I can go over it in little parts, like this. Okay. So first thing that I'm looking at right here is, well, I'll do the Pythagorean theorem again. So Pythagorean theorem, we know that h squared plus b minus x squared is equal to a squared, right? We're looking at the two legs, they get squared and added, equal to the hypotenuse squared. We just have the hypotenuse labeled as a. Okay, and then we just have it flipped around, so the hypotenuse squared is first. All right, so then we're just using a little algebra. We're going to FOIL out that binomial. Right, that binomial is being squared, so b minus x times b minus x becomes right here. We now have a squared plus b squared minus bx plus x squared. We've FOILed it out. That first outer inner last and then still plus the h squared. Okay, now we're just going to consolidate it. So I have minus bx minus bx. That's minus 2bx. Okay, and then here, again, just the same items. Only thing that's different is that we've consolidated the minus bx to minus 2bx. So now here we're going to use some substitution. So if you look at what we did from that first right triangle up here, we've solved for x. X is equivalent to c times cosine A. And we also know that the hypotenuse squared, c squared, equals h squared plus x squared. So I've color-coded just to make it a little easier to understand that what we're doing is we're going to substitute this part here in for the x, and we're going to substitute the c squared in right here for the h squared plus x squared part. Okay, so a little substitution. All right, so now where are we at? So with that c times cosine A in for x, this is now what it looks like. And that c squared in for h squared plus x squared, this is what it looks like. So the last thing to do is just reshuffle it, put the b squared next to the c squared, and then take away 2bc times cosine A. So the only thing that happened to move us into our final structure is we've just put the b squared next to the c squared. So we've written that part together up in front, and then we saved the best for last. So here again, law of cosines, a squared equals b squared plus c squared minus 2bc times cosine A. And in the law of cosines, you are either solving for a missing side, here A, that's if we were given side angle side from the starting point, you'd be solving for the side that's opposite that one angle. And over here, you'd be solving for an angle if you had side, side, side. So you'd always be looking at the angle and the side that's opposite. That's what the two A's are. So an angle with the side opposite, and you are solving for a missing side or a missing angle. All right, have a good rest of your day.